شيء بشكركم على المشاركة معنا الليلة بهالمحاضرة مخصصة لموضوع الفانتوم 4 RTK Pix4D والدي جي اي تيرا برو. بدي اشكر مستر سانجو اللي عم يشاركنا من دبي، اللي هو اختصاصي من دي جي اي بهالمحاضرة. راح يكون في مجال للأسئلة أكيد بآخر السيشن. وبالنسبة لأي تفاصيل تانية أكيد رح نجرب كمان بمرحلة تانية نعمل محاضرة تانية باللغة العربية كاملة هديك، لأنه هلأ رح ينحكى بالإنجليش كل شيء. أوكي. في أي أسئلة ريماركس أو شيء أكيد أيضون، بس حتى في أي شيء أنا أكيد بفضل أنه يتشارك هلأ بهالويبينار. أوكي. أكيد ما راح تكون مسجلة هيدي. أوكي. راح نبلش مع مستر سانجو. أوكي. We are ready to start.
Okay, so you can perhaps turn the audio off from your side so that we can start.
Yeah.
Great. Good evening, everybody. My name is sanju.mathew. I am a sales manager from Aero Motors, DJI Enterprise partner based in Dubai. And I thank the opportunity given from Joseph in getting this event together for talking to customers in Lebanon who are potentially the drone users for surveying and mapping. So our subject is primarily that. So I will try to cover the subjects as slow as possible so that we are all on the same page. During this webinar, we will be muted, but after 30 to 40 minutes, you will be able to talk, or we'll be able to answer your questions. So in between, during the slides, if you have any questions, you can put the questions on your chat box, and then we will answer towards end of the session. Great. Okay. So the webinar theme, which I have come across for you to start, is how to use DJI Phantom4 RTK drone in performing land surveying and to perform 2D and 3D data processing and modeling using Pix4D and DJI Terra, and to generate centimeter level of accuracy data outputs. Outputs like OrthoMaps maps, point cloud, 3D model, XYZ, that's ASCII file, grid DSM, and more. So I will show you these outputs towards end of the session. We will go directly into the softwares. We will also see some process data. Now, DJI Phantom4 RTK is the new generation drone for surveyors, engineers, architects, urban planners, and construction professionals. The agenda will be this for the webinar. We'll have a very quick introduction. We'll also tell you what is member end-to-end drone solution, and then a very deep dive into DJI Phantom4 RTK in terms of applications, where it can be used, what are the features and specifications, what mapping solutions in the terms of options, and what are the important information for surveying and mapping professionals, how the flight is planned, and what data formats you will get from the drone, how the accuracy is maintained, and also you will see the data formats, what will be done after processing. The webinar may take 30 to 40 minutes, and so just keep your attention as much as possible, and then put your questions on the chat box. Thank you. So to start to telling about who's DJI Enterprise, as many of us will be knowing about DJI Enterprise, it's the world's leading enterprise drone manufacturer. Enterprise drone means not the small drones, consumer drones. We are talking about drones that can be used for industry, for different technology, for surveying, for inspections, for solar, different applications. So we are talking about the big drones plus the software and the training. So Aero Motors is a Dubai-based company. They are the DJI Enterprise partner based in Dubai, and we have solutions from drones, camera, LiDAR, software, training, technical support, and also after sales and repair service. What is end-to-end drone solution? This might be new to a couple of people in the room, but if everybody is aware of end-to-end solution, so I'll tell you, just buying a drone will not help you complete surveying and mapping. You need to have a drone. You need to have a flight management platform, which will be also I will discuss in the webinar. Then you have data processing and data analytics. Then you have actionable insights. Actionable insights is once you process the data from the drone, then you will be able to see the visualization in 2D and as well as 3D. Okay, here is our key applications of DJI Phantom RTK drone. So if you see, there are 3 units here. That's the main drone. Then we have the remote controller. Then we have the RTK base station. So this is one of the packages which is a full package. So you do not need to have third-party GPS stations. You also get the coordinates geo-referenced on site. The key applications of using this, many of us will be knowing what are the applications. We do topographic surveys, we do cadastral surveys, site construction surveys, building corridor surveys, roads infrastructure, stockpile, volumetric, engineering surveys, inspection, and 3D modeling. So Phantom4 RTK can be used in these applications and much more, depending on the requirements. So if you have any other application, definitely you can get in touch with us. We will definitely make it work for you. What are the key main specifications of this drone? As many of us would know that we are using GPS from different brands called Trimble, Leica, StoneX, different brands. So the same applies here. The Phantom4 RTK has got a built-in GNSS module. So the GNSS module is capable of receiving GPS satellites, GLONASS, Baidu, and Galileo. It can be purchased with multiple batteries. One battery can fly up to 30 minutes. But this 30 minutes, don't take it very light. This 30 minutes can cover a certain good amount of area. I will also tell you how much area you can cover in 30 minutes in the next slides. It can go up to 7 kilometers of transmission distance. Transmission distance means the distance between the pilot and the drone in terms of above sea level or above ground level. That's what we're talking about, transmission distance. We have something called as OcuSync and TimeSync. That is a transmission system which is patented by DJI, and that's what is being used to keep up this kilometer speed. The position accuracy we guarantee is 1 centimeter, 1 ppm on the drone position in the air, and also in vertical 1.5 centi. So while it captures the data on the air, it will pick up the coordinates and the lat long in the level of accuracy of what I'm talking, 1 centimeter and 1.5 centimeter. It also has a compatibility to work with the DJI On base station. So this is the DJI On base station. And also it can work with third-party base stations. So if you have a third-party base station, let's say like you have StoneX base station or any other brand's base stations, you can work with it in a way called PPK processing. You can't really connect directly on site by radio, but you can always connect by the data while you do the data processing using RINEX files and Nship connectivity. These are the different ways you can use Phantom4 RTK, just I mentioned to you. So you have the basic Phantom4 RTK, then you can use a local net RTK. So that net RTK means if you have a local VRS network, you can also connect to the VRS network and use this RINEX slice data to process in the DJI Terra or Pix4D. So the next combination is that if you want to connect to DJI's base station, that is straight fit. It connects by RTCM, broadcast format on site. Then if you want to use third party, that is any third party receivers, and then you want to use a server plus an Nship, this is also possible. So when you use the Phantom4 RTK, you have a option to add the Nship connectivity. So you can use your server and dial-up settings, and you can connect to the Nship server as well. If you want to use also a portion of it as RTK and a portion as a PPK solution, you can also use that. So there's multiple ways of working on Phantom4 RTK drone. Some of the information which I thought is very important, many very frequently asked questions from many of the people in surveying and mapping and engineering, that they have existing site, they have third-party base stations. So can we connect? Yes, as I mentioned, you can connect it, but you can't connect directly by a radio connectivity, but you can dial up through the Nship protocol. Now, what is Nship? I can explain to you. Nship is basically a format which will be used in getting the GPS data. It's called RINEX. So you will be using the RINEX data in doing the PPK processing while you do it in Pix4D or Terra. What we recommend from as a manufacturer's representative is to go with the first option to connect locally to our own base station, which is like very robust, and we can get real-time results. So why we recommend is that because now the world is moving towards real-time data measurement. So if you're doing a drone-based survey and you want to see your images locally georeferenced at the same time, then the only possibility to do is to use the DRTK2 while you're on site. So you can upload the images on your laptop and process it there and then. So that will give you an absolute accuracy of, we're talking about centimeters. The other way is to connect using a 4G dongle. The 4G dongle comes along with the Phantom4 RTK, the kit. So you can use a SIM card and dial into a custom network RTK in that case. The third option is to use a Wi-Fi hotspot. So if some of the third-party base station receivers, they have Wi-Fi network, you can connect that Wi-Fi network to the Phantom4 RTK controller, and it will be able to give you the georeferencing. Okay, what is difference between Phantom4 RTK and the other drones which you see in the market, like say the smaller drones we're talking about, other consumer drones in DJI? The difference, there is a difference why this is preferred for surveying and mapping. The technical difference is that the camera, what has been with the Phantom4 RTK, it has got a lens distortion recording process, which is not available in the Phantom4 Pro or the other series, because that's not meant for surveying. It's meant for aerial filming and for thermal filming. So this distortion recording process helps to collect the images with the corrections, and it can be used in XMP for post-processing. So that's where the difference comes in, why we need to use Phantom4 RTK for surveying. The second is, there will be a question from many of us, okay, if we're using a real-time GPS and a Phantom4 RTK drone, do we need a ground control? In reality speaking, we do not need a ground control, but if you have a ground control, it's always good to use it as ground control or checkpoints. So you will be able to do a relative accuracy measurement check after you do the data processing. So it's not mandatory, but having it will be good to have a relative accuracy check. So the Phantom4 accuracy, absolute accuracy is meeting 5 centimeter. That is the requirement of 1:500 scale aerial maps. So what is the planning method? So this is basically the type of surveying missions we can do on a Phantom. We have 2D photogrammetry mission. Then we have a 3D photogrammetry mission, waypoint flight, linear flight mission, 3D photogrammetry, terrain awareness mode, and block segmentation. Now, out of these, the most primarily used for surveying and mapping is actually 2D photogrammetry and 3D photogrammetry. We do have 3D photogrammetry in two different ways. One is a double grid, and then we have a multi-oriented grid. Now, what is each of this? I will explain to you in this slide. So 2D surveying mission. So when we say 2D, in the survey world, everybody is interested in getting easting, northing, and elevation, right? So easting, northing, and elevation is basically 3D coordinates. The 2D what is mentioned here is basically not that you're only getting easting, northing. No, that's not the way. You will still get easting, northing, and Z in this particular mission, but your visualization on the screen will be 2D. That means you will be able to see a top view of a map, orthomosaic map. Now, these are the setting screens, what you do before you launch a flight. So ideally, what the workflow will be to upload a KML file from the Google Earth. So you will have a KMZ, and then you can convert into a KML, and that KML can be imported into the controller by directly. And then once you load the KML, it will automatically launch a grid pattern, and then you can set your GSD settings. So if you say that I want to have a GSD 2.74. Now, what is meant by GSD? For the people who do not know what is GSD, I can tell you that GSD is ground sampling distance. Now, ground sampling distance is totally different from the accuracy what surveyors and engineers, they talk about point accuracy. So point accuracy is somewhere related to GSD, but how it is related, I can tell you. GSD is the distance between 2 pixels in a photograph. So if you take a imagery and then you zoom as much as possible, and if you find the smallest pixel you see on the screen, the distance between two of this pixel is called the GST. So if you fly at 100 meters, the math calculation is that 100 divided by 36 will be your ground sampling distance in terms of Phantom. So if you look at this screenshot, it is showing about 0.3 square kilometer, that is 300 square meter, that can be covered in 19 minutes, and you will be able to get 547 images. And once you finish this mission, so 19 minutes means you need only one battery. So if you get more missions, what will happen is, if the flight plan can be 30 minutes, so once you've finish the 30 minutes, the drone will return to the home location, and then it will relaunch back to the previous waypoint by the next battery. So that's about 2D mission. The same thing applies with the 3D. Now, the difference between 2D and 3D is that the 3D missions are used in places where you need, let's say, roof edges, facades, and building corners, and very high-end details. If you need those kind of details where you want to see the visibility of, you want to measure between roof edges and facades, and very, very fine features, then you need to do a photogrammetry mission, 3D photogrammetry double grid. The mission will be longer, it will be lesser area, but it will be very high accurate in terms of imagery. So 2D and 3D missions are what primarily being used in surveying and mapping. The data formats, in addition to the photographs, or let's say the images taken by the Phantom, every format, every flight you do, you will be getting additional some files, which will be system files. If you look at the right-hand side screenshot, if you go down, you will see 5 files. That is eventlog.bim, ppkraw.bin, ppkraw.svg, Rhinex, and timestamp. Now, these are additional file formats what the Phantom generates while it is flying for every mission. The reason being, this flights, one of this is basically to log what has happened during the flight time, like a survey report, what you come from the GPS, something very similar. Then you have a PPK raw file, which is storing the satellite observation and FMS's data. The Rhinex.obs is a Rhinex file format that is created after transcoding, and timestamp is an ASCII format that stores the exposure and time when the picture is taken. So these data formats can be used in different format processing as well as for reporting sake. Okay, this is probably an interesting slide for many of us to understand with Phantom, what can I achieve? Okay, this is where the construction contractors get really very much involved. So this is closely for your information. This is just for an understanding of how much area you can cover in 1 hour using an 80-meter height. So the flying height 80 meter is basically above ground level, or above surface level. With the overlap settings what we speak here and the drone speed of 5 to 6 meters per second, you can get an accuracy of GSD of 2.08 centimeter. And the total productivity in 1 hour, that means with 2 batteries, because one of the batteries will be 25 minutes, so you will fly two times and you will be able to cover 55 hectares. If you don't want 2 centimeter accuracy and you want to cover more area, so you can cover more area with a bit of height further. So by most of the regulations for the flying in most of the countries, 400 feet or 120 meter is kind of like easy permissions. So 120 meter high above ground level is more than sufficient. But in some of the projects, you would be flying at 80 meters. Some you can fly 60 meters, 50 meters. This is all depending on your type of project and what is the feature you need from the ground. So there is no minimum height limitations or something. There is no such kind of thing. So it depends on your project requirement. The other thing which you need to keep in mind is that Phantom4 RTK has got a collision and obstacle avoidance sensing capability. Now, if you are going on a hilly area, and you say that I'm going to fly the mission at 60 meters, whereas the mountain is going to be like 70 meters, and it will not go and crash. It will definitely give you a sensing that there is an obstruction, and then it is up to the pilot to maneuver the route and go to the next plan. So this is a productivity which is So this productivity you wouldn't be able to get in a normal conventional surveying methods using GPS or total stations or levels. Now, we are not saying that they will be replaced, but you could do much more better data productivity using drones, using cut and fill different sites. So it can be much more faster, and you will get a complete 3D data. So with the conventional equipment with GPS and total stations, you wouldn't be able to generate any of these formats. So these are the final data formats, what can be generated from the drone imagery. So you will do a triangulation using aerial photogrammetry software. You can generate a point cloud. So point cloud is running into millions of points. It will be true color. So whatever the color you see on the ground, you will get a point cloud on that particular color. So which is easy to identify and make layers and make classification of point cloud. You will also get a DSM and a DTM. DSM is digital surface model and DTM is digital terrain model. Most of us would know, but I'm just telling to make it more clear what is meant by DSM. DSM, you will get all the features what the images has picked up. It can be buildings, it can be cars, people. So whatever the imagery is taken. So if somebody says that I don't want those things, I want to filter those and I only want terrain. So that's called digital terrain model. There's a way to filter the DSM, remove the unwanted objects and structures, and you will get a DTM. You also will get a georeference orthomosaic map that can be used for CAD drafting. So you can upload the orthomosaic map in a GeoTIFF into ArcGIS Pro or any of the other softwares and do a CAD drafting and make it in layers. You can also calculate and measure distance, areas, and volume, which I will show you in the software. You will be able to generate a 3D model, which is accurate to centimeters. So you can measure between the rooftops, the sides of the roofs, the height of the buildings, anything which will be accurate to centimeters. And for this kind of 3D models, you need to use a 3D photogrammetry grid mission. That's what I explained in the previous slide. You will also get a tile model where you can filter between different type of buildings, vegetation, and we will also have a capability to do automatic power line detection. So there are different softwares which we can use depending on your application. So now that was about Phantom4 RTK. Now we're going into the two softwares which we planned to show during the webinar. That's DJI Terra Pro. That's a software from DJI itself. It is an aerial photogrammetry software which is able to generate OrthoMaps, point clouds, and also the points list. Then we also are going to show you what is Pix4D mapper going to do with the drone data. So that also I will show you on the live screen. Okay, so first I will share my screen on Terra. Allow me to share my screen on DJI Terra. Okay. I hope you can all see the screen, right? So what has happened here is that if you go back, this is the main window of Terra. So I have imported some data sets here. So if you click here, this is basically a 3D model what is generated from Phantom4. So the first thing what you can see is arrow triangulation. So this is basically the arrow triangulation which has happened after the imagery. So once the images are uploaded, you will be able to generate an arrow triangulation by using the local datum settings. So this is generated by the software. Once the arrow triangulation is done, so you can see the point cloud. So many of us would have seen, or for people who have not seen it, this would be a little bit of new thing. This would look like an image for you on a first view, but actually it is not an image. It is basically point cloud. So you will see millions of points being generated on this particular surface. This point cloud file can be exported into different formats. You can say LAS. That's the most popular format. LAS is actually AutoCAD layer object file. So that can be imported directly into CAD, and you will be able to do classification of points based on surfaces, based on vegetation. So this is basically a 3D point cloud, you can see, and you have two options to see the dense and you see two icons here. One is for sparse, less dense point cloud. One is for a high dense point cloud. All right, so this is possible. You can also measure surfaces that I will show you in a while. You can see the height. So this is basically, you will see DSM. So this will be also available as a file format to you. So you can export this DSM into any of the calculations you want to do, cut and fill, or any of those things. The final deliverable is a 3D model. So this is basically a 3D measurement model. So if somebody wants to see what is the, let's do some measurements here. Just go to annotations and measurements. You can, if you want to check what is a coordinate of a point, you can check by clicking this part. Just click any of the points. You will get your easting, northing, and elevation. This is as per local datum here in Dubai. So this, you can save it. And then if you want to measure distance between 2 points, let's say that what is the distance between these two? And right click, you can get the horizontal and straight distance and vertical distance. And then if you want to measure area, let's say what's the area of this total? You can get a projection area and a fitted area. So you can save that. You can also calculate volumes. So if I want to calculate a little bit of volume here, so just for the understanding's sake, let me do a polygon. And then I right click, you get a volume. You have two options in this. You can do it from the main plane, or you can do it from the lowest point. So it'll give you a cut and fill volume, and then this can be used for report's sake. This is basically one of the main things which is available. The same volume and the annotations, you can see it on your point cloud, on your RGB. So you can export these file formats from the DJI Terra into different formats, whatever you like, in Civil 3D or CAD. Okay, so that was basically about DJI Terra. Now I can show you on a Pix4D environment. So let me do it to Pix4D. Right. Okay, so I hope you can all see. So I have actually used the same data file to show you on Pix4D. Okay, so Pix4D, what happens is you create a project, you can upload images into it, then you have a GCP and MTP manager. That is basically, if you want to use ground control, you can use this on a ground control. You can import your GCPs, and then you can also do markings on your GCPs. That is also possible. So to show you what are the outputs you have on the Pix4D, so if I switch off this particular view, so if you look at it, this is how you will see the drone movement has happened, right? So if you ask me, that is how it happens on the waypoints. So this is the waypoints what the drone has picked up, and it will be arrow triangulated, and then these images are processed and stitched. Okay, now if you remove the cameras and the rays, let's only focus on point cloud. So this is now, I remove all the triangle mesh. So this is now your rays and tie points. Okay, this is rays and tie points. Now if I switch on the point cloud, I do have two type of point clouds. One is a densified point cloud. Okay, this is a densified point cloud, and you can use it also in LAS formats, and you can export this and use it in CAD for doing layers and point cloud. So it's already classified by different groups, which is already built in, but you can also add more classes into it, and then you can use this for classification of the points. And if I switch off the points and I switch on the model, that's triangle mesh. So this is a 3D model what is generated from the Pix4D. So if you want to populate both, you just click both. Sorry, not point groups, point clouds. So point cloud and the mesh will populate on the same screen. So from here you can also calculate volumes. The workflow is almost the same, but maybe some of the using the quality level, what you would see on DJI Terra in terms of point cloud is probably much more denser in DJI Terra. So you can go to volume. And if you want to calculate a new volume, let's take a new area. Okay, so let's take a new area here, and I'm going to mark left. And then click compute. Okay, it'll give you a screenshot here for terrain 3D area. What is a cut, what is a fill, and what is the total volume. And if you want this to be generated, copy your measurements on your clipboard and you want to use it in a report, that is possible. If you want to hide it, it's definitely hidden. And if you have to go and do some settings, you want to do a different type of display. So how you want to change the type of display, that can be done. Let's say that I want to do a custom. So if I give, let's say 85, or maybe I'll give 100. So it will display based on that. And then it will be computing again based on that minimum elevation. It will give you a terrain area for it. So then you have an OrthoMosaic. So this is basically a 2D map. So I've shown you 3D point cloud, 3D model, and this is a 2D map. Now on the 2D map, what you can do is you can do measurements as it is. And then you also have functionality to export this as GeoTIFF. So this is actually coordinated. It's geo-referenced, and you can see the resolution of Phantom 4 imagery. It's absolutely stunning, actually. So if you do this kind of 3D photogrammetry missions, you will get a very, very accurate and also high resolution imagery, and you can export this into further engineering drawings and all this. So these are all coordinated for easting, northing, and elevation. So you're pretty much, you do not have to do any ground survey in this case. So you get the total attribute. So you get 3D point cloud, and you also have, so you have the triangle mesh, which is 3D model. Then we say point cloud, then you have GCPs and all of, and then you can also generate reports if you want. So there's a lot of other options you can export into generate quality report. So I will generate a quality report, and let's see what the quality report says. So here it will show you what is the file name, what is the type of camera, what the drone is used, what is the average sampling distance. So it's 2.92 centimeter is the sampling distance, how many medians created, what is the data sets used, 101 images being used. The processing time, if you ask me, it's a good thing to ask. This 100 images took maximum for me is 12 to 15 minutes for processing in one of the softwares. And this is the way it actually has flown. So this is a 3D photogrammetry grid. So this is the waypoint what the drone has started. This is the first waypoint. So it will follow the waypoint. When the battery is almost 25% of the threshold, it will return back to home, or it can return back to any point where you like. So you will again put the second battery. You don't have to do anything. It will just directly come to the previous point where it stopped. So basically it stakes out itself. To make it simple language, it stakes out. That's what the beauty of Phantom4 RTK drone is. So that was about Pix4D. And let me see, I'll just go back to the slides again. So I believe you can all see the screen. So we went through the Phantom4, the DJI Terra Pro. We went through the 3D photogrammetry mission, which is done on Pix4D mapper. So you can generate all these formats, whatever is required. And also these formats, whatever you export it from the softwares, will be saved on your computer, a local hard drive or an external hard drive in these kind of folders. So you will have initial, you will have densification. Densification means point cloud and 3D model. DSM and ortho is a 2D format, so it will be in the OrthoMosaic format. So when you click the densification, you will see three file formats. One is the 3D mesh, that's 3D model, we say 3D mesh. And then you have a point cloud, which is again 3D coordinated. And then if you look at the point cloud file, because most of our industry, they like CAD. AutoCAD is still the industry favorite, and it's being used in construction. So from the drone, you can create a point cloud, which is AutoCAD layer state file, and that is LAS. And you can import it into CAD environment directly, and you can do all your further work, reconstruction work using that. You also will get a very popular format, which is popular amongst all surveyors generally. It's XYZ, Notepad or CSV, we say in different industry languages. So you will get your easting, northing, elevation, and you will also get 3 other values. You do not have to worry on these values. The value of 3 is basically the color of that specific point. So there is a color because you're using true color. So you will have the first color. First will be the red, green, and blue. That's called RGB. So you will get a color number so that you can again filter that, and you can use this points directly into a GPS survey controller or any of the other ground GPS, and they can go and do the rest of the work on site. Great. Now to give you an idea that what are the packages we recommend, or what are the packages available in terms of Phantom, to give you a full solution. That what you need is basically the whole Phantom4 RTK, the drone plus the remote controller and the GPS station. This is a kit, and then you need either of the software. Now the difference between these softwares is primarily, of course, the brand. That's the first thing. Second is that you have a very competitive pricing on the Terra 1-year license, whereas the Pix4D doesn't have a 1-year license at that specific validity. But Pix4D is available on a monthly license and a permanent license. So these are the 2 different variants we have. DJI Terra is pretty much DJI own proprietary software. So as for our first choice is Terra, and we also recommend Pix4D and other softwares. I mean, it can be, the DJI data can go on any of these softwares. It is not mandatory that you have to go with DJI Terra itself, but it's just the user interface. Terra is a little bit more simpler, and it's more faster because it has got a much more faster GPU calculation. So you can use Terra as a recommendation. Now, if you do not want to use the RTK station and you have an existing, let's say, StoneX or Trimble or Leica receiver, you can still go with Phantom4 and the remote controller plus the software, and you can connect using Ntrip or Wi-Fi. That's definitely possible. That was pretty much for today. Actually, I covered as much as I could, and for sure we will have questions. Definitely, you can put your questions on your